Okay, in lesson 1-1, we're looking at all the algebra things you're going to need for pre-calculus. The first thing is finding x and y intercepts. So you got to think about what does an x-intercept mean? That's where it crosses the x-axis, and if it's crossing the x-axis, the y value would be 0. And a y-intercept is where the line or curve is crossing the y-axis, and if it's crossing y, the x value would be 0. So to find x, you plug in 0 for y, and to find y, you would plug in 0 for x. The other method is the cover-up method. So if you're going to make x 0, it's like you're just covering up that term, and you just solve for the y. So you would divide by 3, and y would be 6. And if I cover up the y, which is just making the y term 0, you would divide by 2, and you get 9. And then you should write your answers as ordered pairs. So we've got 9, 0 for the x-intercept and 0, 6 for the y-intercept. On this problem, it's in slope-intercept form. So if you cover up the x, you see the y-intercept is 14. So we've got y is 14. And then if I cover up the y, if I make y 0, I need to do a little bit of solving there. So we're going to subtract 14 to the other side, divide by -2, and you get 7. So the ordered pair would be 7, 0 for the x-intercept, and 0, 14 for the y-intercept. In part C, if you cover up the x, you can solve for y. Just divide the 3 to the other side, and you get 12. If you cover up the y, you would need to divide by the 6 and then take the square root. So let's show that. You would divide by 6 and get 6, take the square root. And whenever you take a square root that wasn't originally in the problem, you got to remember your plus or minus in front of it. So we've got two x-intercepts. We've got positive rad 6 and negative rad 6, and then one y-intercept at 0, 12. In example 2, we've got a point, but we don't know the x value, and it's on a graph of this line, and they want to know what's the a value. So I know the y, I need the x. So I would plug 6 into the y value, and we're going to solve for x. So you want to add 14 to the other side. If you add 14 to 6, you're going to get 20. Then you want to divide by your 3. So x equals 20 thirds, or a is 20 thirds. On C, you're given two ordered pairs, and they want you to find the equation of the line. Because we have 0, 5, that's the y-intercept, so that's the b. And then your slope, remember slope is y2 minus y1 over x2 minus x1. So you can use your points to find your slope. That would be 5 minus 0, the y's, over 0 minus 3, your x's, and you get negative 5 thirds for your m. So it is y equals negative 5 thirds x, and then plus 5. In example 3, we are solving for n. If you're solving for a variable, you need to get that variable all on one side of the equation and then isolate it. So let's start by subtracting 5n over to the 7n. So that's going to give me 2n. Then I want to get all my numbers away from the variable. So we're going to add 9 to the other side and divide by the 2. So n is 10. Over here, you need to distribute first. So we've got 2x plus 4 equals 3x minus 24. And you want to get your variables on the same side, so let's subtract 2x to the other side. So that's going to give me x minus 24, and then I can add 24 to the other side. and x is 28. In example 4, when you've got fractions, you could work with the fractions or you could get rid of your fractions. The problem is easier if you get rid of your fraction. In order to get rid of your fraction, you would need to cancel your denominators. To do that, you multiply by the greatest common multiple, and so, or least common multiple. So your least common multiple here is 6. 2 and 3 both go into 6. So if we multiply everything on top by 6, which you can do because you're doing it to both sides of the equation, which keeps it balanced. Then once you multiply by 6, you can then simplify or reduce each fraction. So here you've got 6 over 2, which reduces to 3. You've got 6 over 3, which reduces to 2. And you've got 6 over 3, which reduces to 2. And so I've got 3 and 1, which makes 3, minus 2 and 1x, which makes 2x. And I've got a 4 and a 2, which makes 8. And now this equation is much easier to solve. There's no fractions in it. So you can subtract 3 to the other side. And then you can divide by the negative 2. And you get negative 5 halves. For B, again, you've got that x in the denominator. So to cancel it, you can multiply everything by x. That would reduce that fraction, and leave an x on the 8. So you've got 6 plus 18 equals 8x. And then you can add those terms together, divide by 8, and you get 3. On C, we want to find the least common multiple for 3, 4, and 6. So if you multiply everything by 12, 3, 4, and 6 all go into 12. Then if I reduce the 3, that would leave a 4 with the x. If I reduce the 4 and the 12, that leaves a 3 with the 1. And if I reduce the 6 and the 12, that leaves a 2 with the 5x. So we're left with 4x plus 3 equals 10x. I've got two variables, get them on the same side, so I'm going to subtract 4x to the other side. And then divide by the 6. So we get 1/2 for the x. In example 5, we're solving radicals. The first thing you want to do is isolate the radical. And then to get rid of your radical, you square both sides. So in part A, the radical is already isolated, so we're going to go to step 2, which is square both sides. And we get x plus 3 equals 25, and then you would just subtract 3 to the other side, which gives you 22. On B, you want to isolate your radical first, so we're going to divide by the 2. And then now the radical is isolated, so you want to square both sides to cancel your radical. Over here, you have to square the top and the bottom for fractions. So you've got x squared over 4 equals x minus 1. And then now that we have an x squared and an x, we need to get them all on the same side. We've got a quadratic now. So I've got x squared over 4 minus x, because I'm subtracting x to the other side, and plus 1, because I'm adding 1 to the other side to set it equal to 0. I don't want a fraction, just like the other problems. We're going to multiply everything by 4 to get rid of that fraction. So we've got x squared minus 4x plus 4. And then we want to factor it. So we want to find two numbers that multiply to make 4 and add up to 4. So this would be x minus 2 to make positive 4 when you multiply, and to make negative 4 when you add. And then if you set each of these equal to 0, you end up getting 2 for both answers. So the answer is 2. In part C, instead of a square root, they expressed it as a rational exponent. So remember, an exponent of 1/2 means square root. So we're going to just square both sides to get rid of it. Another way to think of it is to get rid of the 1/2, you want to raise the exponent to the reciprocal, or multiply the exponent by the reciprocal, which is 2. So it's the same thing as squaring. So 2 cancels your 1/2, and you're left with x squared plus 9 equals then 25. And then you subtract 9 to the other side and take the square root. And since you are taking a square root that wasn't originally there, you get 2 answers. You get positive and negative 4. For D, there's no way to really isolate the radical, so to isolate both radicals, so you want to pick one and isolate it. Let's pick the 2x plus 3, so I'm going to add that other radical to the other side. And then I'm going to square both sides to get rid of this radical. But when I square the right side, I've got 2 terms, so I need to FOIL that. So when I square the left, the radical goes away. When I square the right, I need to write this twice. And so I've got then 1 times 1 is 1. 1 times the radical is the radical. Radical times 1 is the radical. And then radical times radical, the radicals cancel. So you just get x plus 1 plus x plus 1. So then we need to simplify what we can. We've got 2x plus 3 equals, I've got 1 and 1, which makes 2. I've got an x. And then these are matching radicals. So if you add them, you're going to have 2 radical x plus 1. And then here I've got a radical again. So if I can isolate this radical, then I can square both sides to get rid of it. Yeah. So we're going to subtract this x to the other side. Also, let's subtract this 2 to the other side. So I've got now x plus 1 equals 2 rad x plus 1. And let's get rid of the 2. So that cancels the 2. And then now the radical is isolated, I can square both sides to cancel the radical. So that gives me, then I've got x plus 1 squared over 2 squared, which is 4, equals x plus 1. So the radical just went away. Here I need to FOIL that again. So if I FOIL x plus 1 and x plus 1, I will get x squared plus 2x plus 1. This 4 is a little awkward, so let's multiply 4 to the other side. And then let's set it equal to 0. So if I subtract 4x to the other side, I would get negative 2x. If you subtract 4, you get negative 3. We're looking for 2 numbers that multiply to make negative 3 but add up to negative 2. So that would be negative 3 and positive 1. And if you set each of them equal to 0, you get 3 and you get negative 1. In example 6, the radical is isolated. So to get rid of it, you cube both sides because it's a cubed root. 0 times 0 times 0 is 0, and then add 4 to the other side, you get 4. Isolate your radical, so add 13 to the other side. And then, since it's a 4th root, you get rid of it by raising both sides to the 4th power. 4 to the 4th is 256. And then divide by your 2, so you get 128. On C, remember, rational exponents are fractions in the exponent means it's a radical. So same steps, we're going to get the radical by itself. So subtract 10 to the other side.